Hello, I am Chi from Solanica, and I'm going to talk about unified provisioning and management for diverse databases on Kubernetes. So this talk is going to be databases on Kubernetes. So just a little bit about what this talk is going to be. First, I'll introduce Kubernetes operator and complexities of database operators. And then I would like to introduce what OpenEverest operator is, and also how OpenEverest works and what's exciting thing coming up next at OpenEverest. So many of you already know what Kubernetes is, and Kubernetes orchestrate containers, right? It automates deployment. It makes scaling easy, and when the container becomes unhealthy, it can restart it, so on. And Kubernetes operator extends Kubernetes APIs and to the applications. So it's closer to your application logic, and Kubernetes operators reconcile the cluster to the desired state defined by the custom resources specific to your application, and it checks current or actual state of the cluster, and then uses Kubernetes API to create resources like deployment services parts to get it closer to the defined desired state in the CR or custom resource. So how do database operators create a database? First, user defines configuration or the desired state using the operator's custom resource. And then database operator executes control loops to check for what's the current state of based on the CR, and what, if it drifts away from the desired states, or if there's if it needs to create resources, it calls Kubernetes API to create, deployments, services, stateful sets, and so on, secrets, and until it becomes, it reaches closer to the desired state or the desired state. So what does database operators create? So typical database operators may have, proxy layer. This example uses Postgres, so it has, PG bouncer and associated, resources for PG bouncers parts, number of the replicas for that part, and it also defines, how these parts are exposed, whether by cluster IP or load balancer, and it has configuration related to port affinity rule. Then, of course, you would have a Postgres cluster, for this case, database cluster, the number of the instances and replicas, and it may define, it would define resources, and also databases have storage, right? So it defines, where the storage is, the size of it. Another, configuration would be high availability, and this one uses Patroni, and it defines related configuration. It would have a, monitoring configuration defined where the server is, what sort of, credentials or secret it needs, and so on. Backup is another things that are essential for databases. When the schedule, the point in time recovery is enabled or not, and where the storage is for backups. Then related, secrets and users related to the this particular database. So if you were to define this in custom resource, this case, PostgreSQL operators, CR, you would have, what you need for backup, which is quite large. And then, you would define instance of the database itself and high availability configuration, monitoring configuration, and proxy configuration. So it quickly becomes quite complex. And if you think about, for example, scaling is one of the common things you do with Kubernetes. Once you change your configuration, it becomes really difficult to maintain your custom configuration. And particularly often, it's not uncommon for organizations to have multiple databases, and in some cases, multiple different databases as well. So let's look at different database operators, CL. This one's for MySQL operators custom resources. It has, again, how backup is configured, and I guess this one's actually, point-in-time recovery is disabled, but what the backup is, and then HA proxy, which is specific to this MySQL operator, and so on. Again, monitoring configuration. So the challenge with database operator is, while it enables quite easy provisioning at the beginning, given each database operator often provides default setting, you can spin off your databases very easily. But for many cases, these default settings are not sufficient. The databases need to be scaled based on the load, and other configuration may be based on organizational requirement. And once you start drift away from these default, the managing these YAML files quickly becomes very complex. The different databases have different APIs, and custom configurations becomes quickly difficult to maintain, and there's not much conformity between database operators, given underlying tools it uses, like PG bouncer. They're specific for one database, right? So can it be simplified? Database operators share common features, but their specific configurations are unique, custom, and different. So if you have your database, what you would want to do is you want to often common features include scaling. You may want to scale horizontally by adding replicas. You may want to scale vertically by increasing resources. And another one of the feature of the database which you might want to do is configure database engine parameters. Although these configurations are different for Postgres, it would be configuring like PostgreSQL equivalent, but there's a engine parameter that are specific to database that you want to configure. Okay. You may want to define how it's accessed externally, defining connection pooling, load balancers, and either through cluster IP or not. Another thing with common with databases is you have you want to do backup, restore, and point-in recovery, whether it's Postgres, MySQL, or other databases. And these are the actions of you want to do on your database. And finally, monitoring as well. So there are these set of features that you want to apply to databases, but each database operator has quite different configuration for these. So is it possible to abstract these database operators' complexities away? OpenEverest unifies these configurations of common features using OpenEverest custom resources, and it uses Apache 2.0 open source license. So OpenEverest operator has custom resources to define what we saw earlier in the fairly complex YAML that can be defined with just this one single YAML. I'll go through a bit more in detail about what it configures for each features, but idea is that you have a configuration for backup, engine, monitoring, for each separate features. So this configuration actually is for backups. It can be applied to all supported database operators of OpenEverest. So in here, you specify whether point-in-time recovery is enabled. You have scheduling and when's the schedules for backups are, and what's the backup, where's the backup storage is. And another thing you define is, engine parameters, database parameters specifically. So how many replicas you would have, the, resources for these, and the storage, and what type of the database it is. So in fact, I think this type is one of the few places, the only place where it actually defines which database this custom resource corresponds to. OpenEverest actually have a ways to discover available database operators, which I'll talk a bit more in detail later on. And then you would, of course, define, which version of the database you would want to provision. So actually, one of the interesting thing about this custom resources, like, for example, for this monitoring config name, it's references to different custom resources that are that define what monitoring configuration is. This case for PMM. So this defines what sort of what server URL it uses, the API keys, secret where it stores, that sort of thing, and that can be defined once, and it can be reused in elsewhere or other databases as well. So this, by taking common configuration parameters, such as this case monitoring, you can simplify configuration by applying already predefined custom resource onto configuration, for example. Another things that has its own custom resources is pod scheduling policy. Pod scheduling policy here is, like anti-affinity rules. So if you have your primary and replica on the same physical node, that's actually not good, right? Because if your database, if that node goes down, your database goes down. So you want to have them on physically different node when you schedule them. And this is again where you can define the configuration once, or in this case, OpenEverest comes with the default configuration, and then it can be applied to all different databases. And finally, this is how we define proxy, how external access works. Similar to the engine, it allows different definition of how many replicas you want, what type of connection pooling you use. Now, custom resources for MySQL operator, and as you can see, it's very similar to the Postgres operator of the previous slides. So what OpenEverest CR allows is that, you can unify the common configuration, and you don't have to, configure all these difficult fields for different databases. You can just use one custom resource to define the configuration that fits for the databases. I mentioned that I was going to talk a bit more about how OpenEverse discover database operators. So we have another custom resource that we create for each available database operators. So for this case, it's a Postgres operator. And in this custom resource, we define, what are the available images for Postgres is. Like, for example, this one has a version 17.7 and 18.1. And you can also, see what are the available backup it has. So I talked a bit already about the custom resources, but for most users of the OpenEverest, you don't even need to know about those custom resources, because for majority of users and those who are using first time, we have OpenEverest web UI where you can see all of the deployed databases, create databases in just few clicks, and modify provisioned databases, the parameters of the provisioned database, like scaling up and down. So OpenEverest simplifies one step further by providing simple UI to provision supported databases. For example, in this UI, you can actually select number of nodes you want to have for that database. We have a default settings which calculates possible resources that are applicable to the database, or you can specify custom setting if that's your preference as well. So OpenEverest simplifies not only the provisioning of the database, but management of database once it has been deployed. Okay, so now I've shown you a bit about the UI. I want to take you through how OpenEverest creates databases. So for most of the users, you would interface with the web UI. Of course, you can create directly using the custom resources I've talked earlier, but it's the simplest way to create databases using the web UI. So web UI collects, field that's needed to create a database cluster, which is in fact this JSON form is the custom resource that I was showing earlier. So this is exactly the same as that. It's just in a JSON format, and it sends the request to the OpenEverest server, which does some authorization and the validation of the request, and then uses Kubernetes API to create the CR. Then OpenEverest operator uses admission webhooks to sets default values and does validation, either reject it or accept it before it passes to etcd. Then OpenEverest operator starts reconciling necessary CR for whether if the request was for MySQL, it creates the CR for MySQL, or create the CR for this example case. I think it's for the Postgres. Yeah, it creates the CR for Postgres, and it watches the status of that CR to report back what's the status of the database is in the UI that you've seen previously. At the moment, OpenEverest supports MySQL operator, Postgres operator, and MongoDB operator. And we would like to, support, of course, more operators. And the great things about cloud native ecosystem is that there are many operators, like even for databases, there are so many operators where OpenEverest can possibly be integrated. So what's next? At the moment, integrating new databases to OpenEverest is not straightforward. So we are working on our V2 to make it simple to add new databases. So we can support, vector databases, or analytical databases, or other, relational databases. And also we want to look beyond databases. So one of the things is object storage and, possibly other data workloads. So object storage is kind of an interesting one because OpenEverest uses S3 compatible object storage for storing backups, but it doesn't provision that. So that's why it's quite interesting for me. And finally, we also want to integrate with other CNCF operators, such as, popular monitoring operators. So if you're interested, try OpenEverest. And we are also available on OpenEverest users Slack channel in CNCF workspace. And we have a documentation for things you want to find. And thank you for listening.